Welcome back, Year 9, to the journey of indices. Now we're starting to get into the tricky indices today. These are the laws that start to really mess with your head if you don't learn them properly. Now, I want to start by considering an example. So let's have a look at this. I want to consider 2 to the power of 3 over 2 to the power of 5. If I write that out in expanded form, it's 2 times 2 times 2 on the top. On the bottom, there's 2 to the power of 5, so I'll write it out in expanded form. Now we're going to notice that this 2 cancels with this 2. They go into each other once. This 2 and this 2, they can go into each other once. This 2 and this 2, they can go into each other once. And so we're left with an answer that says, on the top, you've got 1 times 1 times 1, which means that you end up with, on the top, 1. On the bottom, you've got 1 times 1 times 1, which I'm not worried about, and you've got 2 times 2. Now 2 times 2 is 4, or it's 2 squared. Doesn't really matter how you think about it. So let's just park that idea for a moment, and let's do the same question again. 2 to the power of 3 over 2 to the power of 5, except instead of writing it out in expanded form, I'm going to use the second law that we talked about, and that is when you're dividing, you look at the powers and you subtract the top power, or you take the top power minus the bottom power, you subtract the powers. So when you look at this one, you've got 2 to the power of 3 minus 5 is, 3 take 5 is minus 2. And there's another way of writing the answer. And so what that's actually saying is this. 1 over 2 squared is actually the same answer as 2 to the power of minus 2. Now, what you can do is you can actually think of that as 2 to the power of minus 2 over 1. You don't normally write things over 1. But if you think of it like that, can you see that if you have something on the bottom of a fraction and you move it to the top, the base stays the same, but the power changes its sign. It changes from positive to negative, and there's the negative that gets introduced. So let's just think about that concept for a moment. If I come over here and I write 1 over 3 to the power of 4. I could move the 3 to the power of 4 across the fraction line. The base stays the same, but the power changes from a plus 4 to a minus 4. And you could write over 1, but you don't. You just stop it like that. If I had something like this one here, 1 over 8 to the power of 16. I can move the 8 to the power of 16 across the fraction line, and it becomes 8 to the power of minus 16. So what we're saying is, when you are dealing with indices, if you ever have a power that's negative, what you're actually doing is writing a fraction without actually expressing it in fraction form. That is the same as 1 over 8 to the power of 16. That is the same as 1 over 3 to the power of 4, and so on. Now let's have a look at the law as it's written in your textbooks. It says, if you have a base to the power of minus 1, that becomes 1 over a. Let me just use the logic I was talking about before. If I have 1 over a, and that would be to the power of 1, I could move that across the fraction line, and it would equal a to the power of not plus 1 now, it would be minus 1. And that is law 1. You need to be able to work forwards and backwards. So if I actually look at this, I can say a to the power of minus 1, which is there, is a fraction where the a to the power of minus 1 now becomes a to the power of plus 1 on the bottom of the fraction. I've got to be able to go both ways. And this is looking at it going in the reverse motion. But instead of using a 1, you can have any power. So we can say something like this. 5 to the power of minus 3 equals, well, that's really like 5 to the power of minus 3 over 1. I can move that across the fraction line, and I end up with a 5 to the power of, not minus 3 anymore, it'll now go to a plus 3. And on the top, you replace it with a 1, because really that's 1 times 5 to the minus 3 on the top. And that's what this law is saying. If you have something written with a negative power, it's actually a fraction. And we've already covered this law here. We did it when we were doing these questions. If you have, well, we did a variation of it. I need to be careful of that. So let me do an example. If I have something like 3 to the power of 5, and for some strange reason I wanted to write it as a fraction, I could think of that as 3 to the power of 5 over 1. The 3 to the power of 5 could move across the fraction line and become 3 to the power of minus 5, and I'd be left with a 1 on the top because that's really 1 times. There are our laws. Let's try applying them to some examples. So here's our first example. Now remember, 4 to the power of minus 1, if you think of it as 4 to the power of minus 1 over 1, you can actually take that 4 to the power of minus 1 and move it across the fraction line, and it becomes 1 over 4 to the power of 1, which is just 1 over 4. I mean, after a while you'll get to the stage where you can just look at it and recognize that anything to the power of minus 1 just means 1 over that number that's in front of it. Let's try our next one. 8 to the power of minus 1. Following this same concept, it's just 1 over 8 to the power of 1, which is just 1 over 8. 100 to the power of minus 1 just becomes 1 over 100 to the power of 1, which is 1 over 100. G to the power of minus 1 becomes 1 over g to the power of 1, which is just 1 over g. So whenever you see anything to the power of negative 1, it's 1 over whatever is in front of the negative 1. Now, example 5 says to write in index form. So if we write this in index form, that means we want to write it, what's another word for index? It is power or exponent. We want to write it as a power. So imagine that k is really k to the power of 1. And you need to move that now across the fraction line, and it'll become 1 times k to the power of minus 1, which is just k to the power of minus 1. Remember, the base doesn't change, but the power will change from being a plus 1 when it goes across the fraction line to becoming a minus 1. So let's look at the next one. If you move the w to the power of 1 across the fraction line, you get w to the power of minus 1. Let's try example number 7. 3 to the power of minus 2. Think of that as being all over 1. Move that across the fraction line because we want to write this in fractional form. And you'll get 1 over 3 squared. Because 3 to the power of minus 2, when you move it across the fraction line, the 3 stays the same, but the power changes from minus 2 to plus 2. And 1 over 3 squared is actually just 1 over 9, if we actually simplify it down. When you're looking at question 8, think of it as 2 to the power of negative 4 over 1. If you move that across the fraction line, it becomes 1 over 2 to the power of 4. And 1 over 2 to the power of 4 is the same as 1 over 16, because 2 to the power of 4 is 16. Now, we want to write with negative indices. Well, if I move the a to the power of 7 across the fraction line, it becomes a to the power of minus 7, and the times 1 out the front doesn't change anything. If I go h to the power of 15 and move it across the fraction line, I end up with 1 times h to the power of minus 15. With example 11, it says to write using only positive powers or indices. So think of the x to the power of minus 3 as x to the power of minus 3 over 1. Move that across the fraction line, and you'll get 1 over x to the power of 3. Now, this is where things get tricky. It says write using positive indices. This part is okay. This part is okay, because that's 2 to the power of 1 and the other one's b to the power of 5, and they have positive powers. The part that's not okay is this part. So if you think of all of that as being over 1, the only part we need to move is the bit that I circled in green, and that's the a to the power of minus 3. And if that gets moved down to the bottom, the 2b to the power of 5 stays on the top of the fraction, and on the bottom we now have a to the power of plus 3. Let's try another one. Got to write using positive indices. Well, that's got a negative power, so I'm going to move it across the fraction line, and it'll become x to the power of plus 4. 1 times x to the power of plus 4 is just x to the power of 4. Now I've got a problem where both sections, or the top of the fraction and the bottom of the fraction, have negative powers. So the top of the fraction is going to move to the bottom of the fraction is going to move to the top, and I'll end up with n to the power of 7 over m to the power of 2. Looking at part E, I'm only worried about writing things with positive indices. The 4 is okay. The f squared is okay. The bit that I need to sort out is the g to the power of minus 3. I move that across the fraction line and I'll get 4 g to the power of 3 over f squared. What about this one? 8 to the power of minus 5. Think of it as being 8 to the power of minus 5 over 1. And I have to have a positive power or positive index. So I'm going to move the 8 to the minus 5 over the fraction line. I'm going to end up with 1 over, because that's really like 1 times 8 to the power of 5. Now you could do 8 to the power of 5 on the calculator, but that's such a big number that we're not going to worry about it. Looking at the next one. Don't worry about the minus 4 having to be changed, because you're only dealing with positive powers, and that's not a power. So the only part that we need to worry about is the 5 to the minus 2. It's going to go to the top of the fraction. So we've got a minus 4 on the top already, and it's going to multiply by 5 squared. And negative 4 times 5 squared is 25. Negative 4 times 25 is minus 100. Now, part H, everything in the bracket is affected by the power. So 3 is raised to the power of minus 2, and 4 is raised to the power of minus 2. Now, because the top of the fraction and the bottom of the fraction have negative powers, we're going to play the switch game, and you'll end up with 4 squared over 3 squared, which is 16 over 9. As you move that across the fraction line in both directions. Time for you to try some questions. Enjoy the experience. Bye for now.